All right, welcome back to another explainer. Today, we're basically turning this session into a high-yield study boot camp. We're going to conquer that computer science syllabus and help you grab absolutely maximum marks on your next paper. We're breaking down exactly how your computer functions behind the scenes, and honestly, more importantly, how you need to communicate that knowledge exactly the way the mark scheme demands. Let's get into it.
Now take a look at this. This is real feedback straight from the examiners themselves. They're telling us exactly where candidates are throwing away points. It literally says students often struggle to distinguish between system software and its actual functions. Okay, so let's tackle this head on and make sure you definitely don't fall into this same trap. We're going to clear up these definitions right now, once and for all.
So, here is our battle plan for today. We're going to cover system versus application software, exploring utility programs, functions of the operating system, the hardware and software stack, and finally, understanding and handling interrupts. Let's kick things off with part 1, system versus application software. Think of system software as your ultimate backstage crew. It's always running in the background, it interacts directly with the physical hardware, and it boots up automatically the second you turn your computer on. We're talking operating systems and device drivers here. Now, on the flip side, application software is what you, the user, actually interact with to get specific things done. It only runs when you actually click on it and tell it to run. So think of things like your word processors, your web browsers, and your spreadsheets. Okay, pause right here, because this is a massive trap that trips up so many students every single year. The paper instructions specifically state, no marks will be awarded for using brand names, 0. So what does this actually mean for you? When the exam asks for an example of application software, do not under any circumstances write Microsoft Word or Google Chrome. You have to use generic terms. Write word processor or web browser. Keep it technical, keep it generic, and lock in those marks.
Moving right along to Section 2, Exploring Utility Programs.
So what actually is a utility program? Well, utility software is just a specific category of system software. While your operating system handles all the broad day-to-day functions, utility software steps in to do the highly specific maintenance tasks. It helps manage, maintain, and control computer resources. Basically, they're the extra tools in your computer's toolbox that make sure the whole system is running as efficiently and securely as possible.
Let's look at a really concrete example that examiners absolutely love seeing. Virus checkers or antivirus software. Now, when you describe what this utility does on a test, don't just write, it stops viruses. You gotta get technical. Tell them it scans for malware like worms and Trojans. But here is the real secret weapon to drop into your answer: heuristic checking. This means the software doesn't just scan a list of known viruses, it actively looks for suspicious behavior in the system. Throwing the phrase heuristic checking onto your exam paper is a guaranteed way to show the examiner you really know your stuff.
All right, Section 3. Let's talk about the absolute boss of the system software, functions of the operating system. If you get asked to define an operating system, you need this perfect two-part definition to get full credit. An OS is the fundamental system software that provides two major things. First, the environment or platform for applications to actually run on. And second, the human-computer interface, or HCI, which is what allows you to actually interact with the machine. Without an OS, your computer would basically just be a useless block of metal. And here they are, the 6 critical management roles of the OS. You need to memorize this exact list. We've got memory management, security management, hardware and peripheral management, file management, multitasking, and user account management. Now remember that examiner report from the very beginning of this explainer? Students often confuse an operating system with its individual functions. Do not give memory management as an example of system software. Memory management is a function of the OS. The OS itself is the system software. You've got to keep those categories distinct in your head. Which brings us to a massive master tutor tip to keep in your back pocket. Whether you're answering a question about the functions of an OS or an IDE, always pair the name of the function with its matching description to hack the mark scheme. So don't just list file management. Take it a step further and explain that it maintains directory structures and handles file naming. Examiners usually give you 1 mark for the name and a 2nd mark for that matching description. Okay, Section 4. Let's look at the hardware and software stack. Let's look at how all these pieces physically and logically stack together to actually run your programs. We're going to read this hierarchy bottom up. Down at the very bottom, you have the physical hardware, your CPU, RAM, and storage. The hardware then runs the firmware, like your bootloader. That firmware then loads and runs the operating system. And finally, sitting right at the very top, the operating system provides the platform to run your application software. It's a literal stack, and every single layer relies entirely on the layer directly underneath it.
But watch out for this common pitfall. The examiner report straight up notes. Few candidates were able to state the purpose of firmware. Some gave imprecise answers, such as, it runs the computer. So the lesson here, don't be imprecise. Let's look back at our stack for a second. Firmware provides low-level hardware control and manages the initial startup. That is the precise technical phrasing you need to lock in to get the points.
Finally, Section 5. Understanding and handling interrupts.
Think of interrupts as the traffic cops of your computer system. Here is your gold standard definition for the exam. An interrupt is a signal sent from a hardware device or from software to the microprocessor to gain its attention. Now, the absolute core concept you must include in your answer is that it forces the CPU to temporarily suspend its current task to handle the request. If you don't mention suspending the task, you're missing the whole point.
So why would a CPU even need to be interrupted in the first place? Well, there are a few exact categories of causes that examiners look for. It could be a hardware fault, like a printer paper jam. It could be user interaction, like you just pressing a key or clicking your mouse. It could be input/output processes requiring more data or timing signals for time-sensitive tasks. But look really closely at that software errors category. A classic exam favorite example of a software interrupt is a division by zero error, or maybe two processes trying to access the exact same memory location. Memorize those specific examples for sure.
All right, lastly, if a long answer question asks exactly how an interrupt is handled, you need to walk the examiner chronologically through the interrupt service routine, or ISR. Step 1, status saving. The CPU hits pause and saves its current status, specifically pushing the program counter to a stack. Step 2, priority check. It checks if this new interrupt actually has a higher priority than whatever it's currently doing. Step 3, ISR execution. If the priority is higher, the CPU loads the start address of the interrupt handler into the program counter. And finally, Step 4, restoration. Once the interrupt is handled, the saved status is reinstated and the original process resumes exactly where it left off. You just lay out this step-by-step logic and you're golden. Well, we've definitely covered a lot of ground today, from dodging brand name traps to defining the exact steps of an interrupt service routine. You've got the exact terminology, you've got the specific examples, and you have the examiner secrets right at your fingertips. So the real question is, when you sit down in that exam hall and see a question on system architecture, are you going to blend in with all the generic answers? Or are you going to use this exact structural stack to basically hack the mark scheme? Take these frameworks, apply them to your practice questions, and go ace that exam. Thanks so much for joining me for this explainer, and happy studying.